Hi, welcome back to the Cosmic Classroom. We'll talk about Newton's first law of motion now, inertia. So, inertia is the body's tendency to remain at rest or to remain moving in a straight line at constant speed unless acted upon by an external force, by an outside force. If you Google, that's what you'll find. I like to state it a little bit differently. I like to say that inertia, because of inertia, the motion of an object remains the same unless acted upon by an outside force. So an object doesn't want to move unless something external makes it move. Okay. So, for example, if you're traveling on an airplane, if you don't look outside the window, you don't know if you're still sitting on the ground or if you're traveling, because the external forces of air and drag are not in direct contact with you. The plane is shooting you from there, so you're traveling, and for you, you can't tell the difference between being at rest and traveling at constant velocity. If external forces were acting on you, you would be able to see it for sure. You would feel that. So if there is an external force, the motion is then changed, and that can be felt. So, for example, a rocket will stay coasting in space at a straight line at constant speed if no external forces act on it. The problem with understanding inertia is that the world that we live in is full of friction. But in the case of a hockey puck, for example, there isn't much friction between a hockey puck and ice. So observing a hockey puck gliding through ice gives you an idea that if there isn't an external force, if that hockey puck doesn't hit something, doesn't hit a wall, or another player doesn't hit it, it will continue traveling at constant velocity because there's very little friction, there's very little of external force, right? Outside force. And another example of inertia is when you're traveling in a car, right? And that's why we need airbags, because you're traveling with the car. If the car comes to a stop because it hits something, you are not going to want to come to a stop because of inertia. You're going to want to continue moving with that same velocity you had before, with that same speed. You're going to continue in that same motion. And you need something to stop you because the car is stopping. It's better to be stopped by airbag than by the windshield, right? So that's why we have airbags. Now here I have a really simple demo of inertia, okay? So let's look at a glass, and I tried to find something that doesn't have much friction at all. So I found my CVS card. You can feel free to use it and give me the rewards. That's fine. The number is right there. So that's the CVS card. And I'm going to put a coin on top of it. Now everything is at rest, okay? Everything is at rest. And the coin wants to remain at rest. It doesn't want to go anywhere else, right? Because of inertia. So does the CVS card, so does the glass. I will apply an external force to the card. The card will move through. Because there isn't much friction between the glass and the card, and between the coin and the card, this force that I will apply in the card will not be transmitted very much to either the coin or the glass, okay? So if I give it a push, let's try again. I swear I practice at home. It works really well. Guess I'm afraid of being, there you go. All right. So you see, if there isn't much friction between the card and the coin falls right in, because the coin doesn't want to move. The coin wants to stay in the same state of motion. That state of motion was sitting on top of the cup, and that's where it stays. All right? So I think that's it for inertia. I hope it helped you. See you next time.